So in this class, we'll do the last 3 questions, okay, on textbook page 120 of this test 8F portion. So let's go to question 7 first, which is on textbook. You'll find on page 120, okay. So open your textbook to page number 120. Let's see the question there. I'll read the question for us. A ball is gently dropped from a height of 20 meters. So let us deal with that first. So there was a ball and that was dropped, means fall in a downward direction. Before it was released, it was at a height of 20 meters. So here, the first sentence of the question is saying the ball is dropped. The ball is dropped from a height of 20 meters. So let us do that. From a height of 20 meters, okay. So that means this word dropped, we need to keep that in mind. So here the initial velocity u will be 0 meter per second. That is your initial velocity. We have done this in the previous class also, right? That when an object is dropped from a height, before it was gently released, it was stationary, it means at rest. So that means initial velocity, it was not moving, so 0 meter per second. We know that because it is dropped. We know that if it was thrown upwards, then at the highest height, the final velocity would have been 0, v would have been 0. It was thrown upwards. We discussed it in the last class. But today it is being dropped. So just before being released, it was stationary. So u is 0 for any object that is dropped, like this ball that is being dropped, okay. So that is it. Then this 20 meter is nothing but the height. S equal to 20 meter is the height from which the ball was dropped. Let us read the next sentence of the question. It says, if its velocity increases uniformly. So clearly question is saying that since its velocity increases, so this is a very important word here, increases uniformly, okay, uniformly at the rate of 10 meter per second square. Now here, even if the question did not tell us that the velocity of this ball that is dropped is increasing uniformly, we should understand ourselves, because from our daily life experience also, when you drop a ball or an object from the height of a building, then when you release it, it was slow, velocity was less, but as it goes lower and lower, velocity increases, and velocity is highest just when it strikes the ground. So for an object that is dropped, velocity always increases along the way. For an object that is thrown upwards, velocity decreases along the way, right? So for any object in which velocity increases, we know acceleration is always positive. We've discussed this again and again, positive, negative acceleration, because this is very important for us to get with clarity, okay. So for example, a car is increasing its speed. So for an object that is increasing its velocity or speed, like a car increasing its velocity, or for a ball that is dropped and the velocity is increasing as it goes down, the acceleration is always positive. For negative acceleration, the picture is that of a ball being thrown up, so that as it goes up more and more, the velocity decreases, right? Or a car applies a brake and the car begins to slow down. That is the picture of a negative acceleration. But here, since the object is dropped, it is definitely positive acceleration, okay. So now, what is the question asking us? After what time will it strike the ground? So that is, they're talking about t. So let us write there t, time. And then I think before that, with what velocity will it strike the ground? They're asking the velocity first. So velocity with which it strike the ground is nothing but the final velocity. So velocity with which it strike the ground, the velocity with which the ball touches the ground, that means. So that will be the highest velocity, that is final velocity. Then next one is time they're asking. So let us see there. After what time will it strike the ground? So time taken to strike the ground, in other words. So time taken to strike the ground. So these two here, V and T, we have to find out. And as we have said, this chapter is motion, and we are almost in 80-90% of your numericals. Invariably, we are going to have to use these three famous equations of motion. So we need to keep those three equations well memorized, that we easily remember them. Okay, so here to find V, see here, first formula, if we check properly, then here we know U is 0 here. See, you can see here A is plus 10 and T is not yet there. So we cannot use this now to find your V. Then the third formula seems to be right. U is 0, A is there, S is there. So the third formula, we cannot use the first formula because we don't have T. But the last third formula does not have T, and we know U, A, and S. Out of 4 physical quantities, A, S, V, and U, you know already 3 given in the question. So we can shift the rest and get V square. V rather. So here, since we know about the third equation of motion, twice AS is equal to V square minus U square, right? So we have one V, so don't move that. So we didn't move this. Then this also don't move, 2AS. Then if we shift this to this side, it become minus, will become plus U square. I hope you're getting it. Right? So let us deal with this. 2 into A, sorry, here plus 10, so we can just write 10 meter per second square if you like. Okay, and then into, or this is S, they're not going to cancel, so you can just write it here itself if you want. Into S is here, 20 meter. Everything is in SI unit, so that is fine. Plus, be careful with this, U. As you can see here, it is 0. So we can just write there 0 meter per second. But we have to be careful to put a whole thing, bracket, and square here. Because it is U, not U, U square. Right? So that it will imply V square, if I remove the square, then we know root comes on the other side. This is very easy. So here 2 2's are 4 and 2 zeros are there, so it will be 400. Meter into meter is meter square. And here's second to the power minus 2. And we can neglect this part plus 0 because 0 square is 0 only. So next here, take only this 4. Forget about, don't think about the 2 zeros now. 4 means we know 2 2's are 4. So double 2 will come out of the root as single 2. And then take the next 2 zeros, which is 100. 100 is nothing but 10 into 10. So double 10 will come out as single 10. So 2 into 10, which means simply we can write it as, and then meter square will come out. Meter square means meter into meter. So double meter will come out single meter. Second to the power minus 2 means minus 1 into second to the power minus 1. So double will come out as single. That's how we take out the quantities from inside the square root to the outside, right? So the velocity with which it strikes the ground is 20 meter per second. So you can write here velocity with which it strike, velocity with which it strike the ground, which we have taken in the beginning as V, is equal to 20 meter per second. So that is our answer for this one v. Now we need to find t. So this time here we have this one already. U is 0, v just now we found out, a is there, 10 meter per second square. So v u a is there, so we can shift a u v to one side and find out t. So we can use the first equation now. So let us do that here. Maybe we can just do here. So here, from here we're coming to here. So next here, since the first famous equation is v is equal to u plus a t. So the secret behind doing these sums is that we don't hurry but think carefully and do. Okay, then it's quite easy. So that is, we know by now, so we'll just shorten it. Don't move this, so t, at, okay, and then this don't move and shift this one this side, means minus u, because no sign is plus. It should become minus u. Then from here itself you shift this a, then it will come down, because a into t means a will go to the denominator. So this is the next step, t. So I'm just shortening the steps. I hope you're getting it. The next here, that will be equal to v, we just found out there, so we added 120, minus u, though in the beginning we have written on your notebook now, 0, and unit is meter per second, so you can take that out as a common factor. Okay, now once you're through with that, a, here we can see plus 10 meter per second square. Do carefully and thinking a lot, it helps you, makes it really easy if you do that. So 20 minus 0 is simple case of 20, and here meter per second, this one, by 10 meter per second square. Please note that this is second square. Then 0 0 cancel, meter cancel, second to the power minus 1 gone, means 2 minus 1 is still minus 1 is there. Okay, then here 2 is left, 2 by 1 means 2. Second to the power minus 1, if you shift up, it will become second to the power plus 1. For plus 1 power, we never write. So the time is this one, 2 seconds. So your next answer is time taken there. Therefore, time taken to strike the ground, means to reach the ground, in other words, which is denoted by us as t is equal to 2 seconds. So this is your second answer, this is your first answer. Okay, so 7. We'll go to 11. Okay, 11. As I said, this is the last numerical, okay, of this chapter. There are 6 numerical tests. F is the last one. Okay, so let us go and see the next one. Okay, so before we go to the next one, okay, before that, question number 11, textbook, page 120. Okay, so before we go to the next one, let me tell you something. Now, if these videos are helping you to understand and you like these videos, then please share it to your friends also, and then ask them to subscribe if it is helping them. And if any of you are interested in taking up tuition, then we have we give tuitions, normal tuitions, in classroom tuitions. The tuition center is at AGRI farm, okay, just near Ministers Hill Baptist Higher Secondary School. But if your home is too far from there and you cannot come to take, then there is also online tuition. And the online tuition is such that videos will be uploaded and then we will send it daily. You will be added on a WhatsApp group, and then videos will be sent portion every day. And then you'll have to do those videos. And then advantage of taking tuition is that online is also used, that you'll get the question papers. Once you finish this portion, you will get a question paper that is identical. Everything is identical except number is changed, and you do that and you will really improve. Every year students have said that, those who have taken this test regularly, that during their school exams, final exams and main exams in school, they don't have to study these physics or science portions, or if it is maths, then maths and science so much they can concentrate on other subjects. This is consistently something that students every year they tell, those who come regularly and take the test. Okay, so and the contact number is given after each video at the bottom there is a contact number, so you can contact us, and then if you have questions we will answer your questions and you can join. If not, also you can freely use the videos, you can subscribe, and that is free. The only difference is that if you do that, then you won't be getting the question papers, but all the sums will be solved. And one thing is that all the numericals in physics, okay, or any chapter, maths, science, class 10 also, 9 also, all the numericals in the text, okay, are solved. And then you will really improve if you just follow it sincerely, okay. So let's go to the next question, 11. So let me read the question for us, okay. If a sports car go from rest to 27 meter per second in 9 seconds, so here, since the sports car, okay, go from rest, okay, from rest, so this is a keyword, to 27 meter per second in 9 seconds. That's what the question is saying. So let us write here, these are the important values, physical quantities that we're going to get. Rest means initial velocity we know is 0 meter per second. That means the sports car was not moving in the beginning, okay. Then it reached 27, means there's a final velocity. 27 meter per second is the final velocity. 9 seconds means we all know that is time taken, so 9 seconds is the time taken for this car to reach from rest to high speed of 27. It took 9 seconds, okay. With this information, question is saying what is the magnitude of its acceleration. So we have here A, we have to find out. Definitely this is going to be positive acceleration, because from 0 to 27 means the velocity is increasing. Velocity increasing is positive acceleration. Velocity decreasing, like a car slowing down by brakes, is negative acceleration, but this is positive. So by now also we know our A should come out plus. So now since here, look at the three famous equation, we need A, we have U, V, T. So here we have U, we have V, we have T. All we need to find is that A. So that first one is perfect equation to use. So since we know V is equal to U plus AT, we need A, so don't move AT, don't move V, and shift this one U this side and minus U. Then we need A, so let us just shift it here itself. So let T shift, then it will come down. So A will be equal to this. This is our formula, right? V minus U divided by T. So now it's a matter of just putting the right values in the right places. V here is given 27, so let us write there. Minus U is here 0, and common unit is meter per second. Then T is here 9 seconds. So 9.0 means we can simply write it as 9. Okay, so here that will be equal to so if you move from here to here, that will be equal to 27 minus 0 is 27 divided by down there 9 meter per second. We can see here this one, and you shift this one to the numerator. Second to the power plus 1 will become another second to the power minus 1. So 9 3s are 27, so this is 3 meter per second to the power minus 1. Minus 1 means minus 2, which is clearly positive. This is what the question is asking us. So since it's positive, what does that tell us? Therefore, acceleration of the, or acceleration is, you can just simply put it, acceleration is 3 meter per second square, comma, in the direction of motion, okay, in the direction of motion of the sports car. So that's our answer. They are asking only acceleration. Okay, then one more question, 12. So let us do that, 12. Okay, so in the 12 here, let me read the question for us. Question says, in a test of safety restraint, a test car was slowed down. So this time slowed down, negative acceleration, 50 meters per second to rest. So since car was slowed down, okay, slowed down. Since car was slowed down from 50 meters per second, 50 meters per second, keywords, to rest, another keyword that will give us a physical quantity, in a time of 0.40 seconds, another important information. So with this we can collect these informations here, that is here we will get slowed down means negative acceleration, but this is velocity, meter per second. How do you know this velocity? Because the SI unit is meter per second means velocity. So initial, that is first one is initial 50, so it was at a high speed. This is your initial velocity. Okay, this was your initial velocity. Then finally it came to rest, means there's a final velocity. Rest means not moving anymore, stopped, so 0 meters per second, final velocity. Then second means time, so there is 0.40 seconds is the time taken for the car to go from high 50 meters per second to stoppage. It took 0.4 seconds after application of brakes, maybe. Just because that's the only way you can stop a car, right? A, so A, they're asking you, what acceleration was this? So they're asking for A. So this is the acceleration. Definitely this time it will be negative because it's slowing down, see? Increasing means 50 to 100 means positive, but 50 to 0 is decreasing. Then B, you have to find out. How far did that car travel in this time? So S is the distance traveled. Okay, so this will be the two quantities that we will need. Now we have to think a little bit and see how you're going to do this. Now here we have U, V, T. So see here, U is there, V is there, T is there. You can easily use the first one to find out A. So you can just start that. A, since we know V is equal to U plus AT, that implies, or that, yeah, that implies A will be equal to V minus U divided by T. I think you are already done just now, so you know what is this shifting, right? So that will give you V is here 0 minus U is here 50. Common unit is meter per second divided by T. And so T is here 0.4 second. Okay, so be careful with that. Now here, sorry, 0 minus 50 is minus 50. 50 minus 0 is plus 50, but 0 minus 50 is, the minus belongs to 50, so it will be minus 50. Be careful with that. Divided by 0.4. Okay, so here meter per second, and you can shift this one up here itself if you want. Second per second plus 1 will become minus 1 power as you shift to the numerator from the denominator. So we can see here one decimal place. Now it is uncomfortable dealing with decimals in the, especially in denominator, so let us remove. One decimal place means multiply by 1 0, then decimal will jump to the right, that's why we're multiplying. So same number we have to do up also. So this is minus 500, 1 0 added here, divided by okay, divided by, so here meter second to the power minus 1 is minus 2. Then here 0.4 into 10 means decimal move right, so no more decimal. So this 0 has been used up here. So now 4 ones are 4, 1 in hand, 10, 4 2s are 8, 9, 10. Right, so 2 in hand, 4 5s are 20. So it is minus 125 meter per second square, which is clearly negative. That means minus. That's correct, because the car is slowing from 50 to 0 means surely it should come out negative acceleration. So we will write our answer like this. Therefore, acceleration is minus 125. We can write like that, meter per second square. Or even if you don't write the minus, it's fine in the last step. But if you want, you can write, okay, in the direction opposite to the motion of the car, okay, because it is negative. Now next we have to find S, so let us do that. Okay, maybe you can use this side. So from here you just go, okay, so here, from here, okay, you know, so let's go B. A is done, so B. So S is equal to here, you can use any of these two. I think S equal to U is there, T is there, time, right, and A is there, T is there. Just now A you found out. Or you can use this 2A is equal to V square minus U square, because you know A just now we found out, V is there, U is there. But we can just use the second one, I think, arrange. So UT plus half AT square. You can use any of these two. The answer will be same. Okay, so here there will be U is here, you can see 50 meter per second into, like that you can write, or you can slant it also if you want it, into second to the power minus 1 brought down means plus 1 now. T is here 0.40 means 0.4 only second. That way these two will cancel. That's why we're bringing it down. Plus half into A just now there, minus 125 meter per second square. Be careful with that. Into T square. So T is here 0.4. So T square will be 0.4 into, okay, you can use here into 0.4 into 0.4 and second into second square. That way this second square here will cancel this second square, gone. And then you can also cancel this into, so 2 ones are 2, 2 zeros are 0, 2 twos are 4, so 0.2. Then here you can use this 0 to shift this decimal to the right, then it become no more decimal, so no more 0 here also. So 4 5s are 20. 0 is used up, so don't put 0 again. 4 5s are 20. Here meter, only meter is left. Plus into minus is, let us deal with the sign first. Plus into minus, minus. Minus into plus, minus. Minus into plus, minus. So minus is the sign. Then here 2 4s are 8. So let us do that. 8. And then 1 2 decimal, so 1 and 2. So 0.08 when you multiply these two. Multiply that to this 125. So 8 5s are 40. Right? 8 2s are 16 plus 4 is 20. 8 1s are 8, 9, 10. 1 2 places, so 10. So we're going to get here minus 10. When you multiply all these three, you will get minus 10. Here minus 10, and only meter left. So this is just a case of 20 minus 10 is plus 10. So we can write our answer. Distance traveled. Distance traveled, which we have used as S, will be equal to 10 meter. So this is the last question. First answer here acceleration and the distance traveled. Now go and give the test. The test is, every question is identical and only number is changed slightly. If you take the test immediately after the class, you will really don't have to study so much before exam, okay? It'll make things so easy for you, okay?